All right, this is my lesson video for section 8.4. It's our second video on distribution of data. Previously, we learned how to do box plots. Today, we're going to learn how to make a histogram with our calculator, and we're going to learn how to describe the distributions in context with appropriate summary statistics. Tomorrow, we're going to learn how to describe box plots in context. Okay, when we are analyzing univariate statistical data, univariate just means one particular data point, one variable, as opposed to bivariate, which is then two variables, an X and Y data, and one would be a bivariate set of data. When we have a univariate statistical data, we want to give a good description of that data. To do this, we must describe the shape, the center, and the spread, and we need to do it in context. The first, let's talk about shape. Is it roughly symmetrical? So down here, I have a symmetrical distribution of univariate data that's been displayed in a histogram, and you can see that it is very symmetrical. Does it have one or more peak or modes? And in this symmetrical set of data, I have one peak or mode. Is it skewed to the right or to the left? This data over here essentially has skewed right. What does that mean? From the symmetrical data, I have essentially pulled data points to the right of the median, and it essentially creates a tail to the right. And so the tail indicates how it's been skewed. So if the tail is to the right, then it has been skewed positive, or you can also describe it right skewed, as it is in this picture. And in this case, I have pulled data, or data has been shifted to the left of the median. Now I have more data points to the left of the median, and I have now a negative or left skewed distribution of data. Okay. So we would describe shape. Is it symmetric? Has it been skewed to the right or positive, or to the left or negative? We might also want to discuss if there's any outliers. So if I had another bar way out here, that might be an outlier. Or maybe if there was a gap in the histogram. So maybe I would have this right here, I just highlighted in blue, go away. We would maybe bring that up. Okay, outliers should not be discarded without good reason. Sometimes they are the most important data points. If a distribution has outliers, you need to comment on their presence. Okay, all right, so that's how we would describe shape. Symmetric, skewed right, skewed left, any outliers, gaps. If there's one or two more, especially if there were two modes or two peaks, we would want to bring that up. Center, approximately what is the middle, or which could be the median or the mean of the data. And we would make sure we would describe, were we giving the average or the median. Okay. Spread, how variable is the data? We could use different types of statistics for that. We could describe the range of the data, standard deviation, variance, and interquartile range are common statistics that can be used to measure the spread of the data. Okay, so how much is the spread? Okay, now when we're describing the shape of a distribution, we're not going to worry about little bumps. Imagine if you were to drape a tablecloth over the graph, where the little bumps would have been smoothed out. So let's take a look at what we're talking about here. So if I just had this histogram here, and you would see this massive drop here, that if you were to drop a tablecloth on top of that, you're really just focusing on that shape, right? We're not, I'm terrible at that. So let me try it again. So there we go. So this is a skewed right. Well, it was supposed to be skewed right. And as opposed to a symmetrical graph, which would be something that would look more like that. Okay. Okay. So we're kind of looking at the smooth image of that histogram, okay? All right, in a symmetric distribution, the mean and median are close together, all right? So sure enough, if we look up here in the symmetrical, we see that the mean and median are essentially in the same location. In a skewed distribution, the mean has been pulled away from the median, and it's going to move towards the tail by the data values that are in the tail and far from the median. So let's take a look at my right skewed data. You can see that the median is still relative, basically in the middle, but the mean has shifted to the right of the median because I have data points, so many more data points to the right of the median that the average starts to shift to the right. Same happens over here when I have a skewed left. The median is still in the middle, but the mean has shifted to the left. So the mean will shift in the direction of the tail, okay? Outliers will also, if I had an outlier out here, will also affect the average, right? Because that makes sense. I have to add all the numbers and divide by the total numbers, and that will also shift my mean or my average, but it will not affect my median. So as a result, very little that is, we consider our median to be resistant measure, while mean is non-resistant, okay? Mean is non-resistant. It will have changes to it as the shape changes, okay? However, like mean, the standard deviation is also non-resistant and can be significantly affected by the shape of a distribution and outliers. So the larger the spread, the larger the standard deviation. And if I have outliers, the larger the standard deviation, okay? Why do we bring this up? Because this is going to help us determine what statistics we use when we describe a distribution, okay? So how do we choose? When choosing a measure of center and spread to describe a distribution, I'm in this box right here, first examine the shape. If the distribution is reasonably symmetrical and free of outliers, then we will use the mean and the standard deviation, okay? However, if the distribution is skewed or has strong outliers, then we're going to use the 5-number summary, the minimum, the quartile 1, median, quartile 3, and maximum. And they usually provide a better summary of the overall pattern, okay, because we will have an impact of the change in shape as well as any outliers, okay? So that will determine how we choose our statistics. So let's figure out how this works. You're going to need your calculator. Okay, so let's get out your TI 85, or sorry, 84, and let's get ready to do some of these together. All right, so the example that is given is the laboratory grades of a student in a biology class are given in the table to the right. Using your graphing calculator, make a histogram of the data and use it to describe the distribution in context. So we're going to use our graphing calculator to create a histogram. So the first thing we're going to do is we're going to hit the stat button, and we will hit enter for edit, and we will enter in all of this data into list 1. So if you have some data in list 1, you can go to the very top. On top of list 1, hit clear and enter, and it'll clear all your data points. And then you can go ahead and manually enter that. So pause your video, enter in that data so you can follow along. Okay, I hope that you have now completed that. Now that you have entered in your data into list 1, we are going to create a statistical plot. So how do we do that? We will hit second function and we will hit stat plot, which is above our y equal. So we'll hit second function y equal, and we will select plot 1, and we should see this screen here. And we will make sure that we have turned it on, and we will select this histogram shape instead of a box of whisker or a scatter plot. which we've had. Now you'll make sure that you have selected the correct location where your data is. Frequency, each data point is only representative one time, so we're not going to change that. And we're going to then hit zoom. So anytime we have entered data into a statistical plot, we can go to zoom and then select option 9, which is zoom stats, and it will automatically adjust our window features for us. So you should now have a graph that does not look like this. Okay, it's actually been the calculator gets us close to what our window needs to be at that point, but not exactly perfect. And so we're going to need to make some adjustments to that window because of, okay. So now what we're going to do is go and select the window button over here, and you will see this screen, and the data that's there, it will show, it should show something around 63, 103, and I believe 5.8. So we're going to focus on these X-min, X-max, and scale. Okay, and so what we want to do is we want these numbers to be convenient for our human eyes, okay, so to speak. And we don't want a decimal point for the scale, for sure. We want a whole number. And whatever the min and max is, we need our min and max to be divisible by that scale. So for example, it was originally 60, but we could have, I'm sorry, 63. And so we would maybe select 60. And originally it was 103.8. So we want to go a little bit higher than that. So let me back up. Originally this was 63. So we want to make our minimum slightly lower than that, and something that's divisible by whatever our scale is going to be. So 60 is a good number. Originally it was 103.8. And so we went a little bit larger than that and we made it 105. And then I can select a scale of 5, and 60 is divisible by 5, and 105 is divisible by 5, and I would get a whole number. Now, if I chose, for example, 110, I'm sorry, if I were to choose something like a 10 here for my scale, I would maybe need to increase that 105 to 110 so it was divisible by 10, if that makes sense. Now, if you put in 60, 105, and 5, you will see a much nicer looking histogram that has selections that are more convenient for the human eye. And let's see, 105, 5. Oh, okay. How do I get to that? You would then go and select, after you entered in 60, 105, and 5, you would just go and select graph. And now you have this screen, which is our histogram. Okay, so now we've got a really nice looking histogram. Here we go. All right, now we need to go look at some data. And so what we need to do now is we need to go back to stats. Let me clear this out. So we're going to go to statistics again. We're going to scroll over to calculate. Okay. We are going to select one variable statistics. And we're going to tell it, we're going to select the data that is located in list 1. We're not going to increase the frequency for any particular data set, and we'll hit calculate. And we now should be in this screen. And if you'll notice, because of this arrow down here, that means there's more data. And if you scroll down, you'll see the second screen. Okay, so now we have all of our statistical data for list 1. We have the average X bar, and we have the standard deviation for either a sample or a population. And we have our 5-number summary on the second page. So now we have to learn, so we now have to describe, shape, center, and spread using the correct sample statistics. So since this histogram here is symmetrical, reasonably symmetrical, we will, based on this, use our mean and our standard deviations. So the first thing we need to do is discuss in context the shape. So what is this in context? What is this data? This is laboratory grades of students in a biology class. So we're going to discuss the shape. So the distribution of laboratory grades of students in a biology class, we want to be specific, is roughly symmetric. So we have discussed its shape, and now we'll discuss its center with and since it's symmetric, we're going to use the mean, with a mean of, and we can go find that. Here is my mean of 81.25%. And then we will discuss our range and a standard deviation. And since we have taken a sample of the entire class, the laboratory grades of the students in a biology class, we have the entire class, and that's what we're talking about. We're going to use this standard deviation for the population, which is sigma, and that will be 9.2, we'll call it 29%. Okay, and so that's how we would describe. So we have described the distribution of laboratory grades of students in a biology class is symmetric. So there's the shape. We have, with the mean of 81%, there's the center, and a standard deviation of 9.28%. There is the spread. All right, let's try another one. You could try it yourself, and then we will go over it together. All right, welcome back. And so basically, we will have entered in this data into our calculator, into list. Okay, so we've entered in our data into list 1. So we would have gone to statistics, hit edit, entered the data into list 1. We would have gone to Zoom. That would have been this key right here. We would have selected option 9 for Zoom statistics, and then it would have given us a graph that's not exactly perfect. So it would have originally been 7. Now I got to go adjust my window just a little bit. Originally the X-min was 7, and the X-max was 26.2, and the X scale was 3.2. Now what we need to do is make X minimum a little bit smaller, and maybe the scale, we're going to make it 3. And then, so what do we have to go to in order for it to be divisible by 3? And that would be 6. And if instead of 26, we'll go up to 27, that's also divisible by 3. And then we made this 3. So then I just changed X min to 6, X max to 27, and the scale for X to be 3. And if you do that, if you kind of stay as close to those as possible, you got to go a little bit lower than the min, a little bit greater than the max, and then just adjust that scale so that you both of those min and max are divisible by it. Then you'll get a nice looking graph. And now we can select graph, which is over here on this side after we've adjusted our window, and you should see this histogram over here. Okay. I played with these and kind of made it maybe as low as 5 and as high as 30, and the scale is 5, and you should do that too, so you can see. Then it's a little bit more difficult to see the skew, and so stay close to what the calculator calculates. You got to go a little bit below the min, a little bit above it, and adjust the scale as little as possible such that you have a whole number when you divide those two by that. So I hope that makes sense. Now I have this nice histogram, and you can hopefully see that it's skewed. And which way is it skewed? It's skewed left because the tail is to the left. Okay, now we're going to also need to be able to see some statistics data about it. So what do? We have to go to statistics again, and we go to calculate under stat. So we have to scroll over one, and we'll select option one, which is one variable statistics, and select list one, and you should see these two windows when you scroll down. Okay, so now we have all of our data. And the instructions above were if the data is skewed and not symmetrical, then we will have to use the 5-number summary. So let's talk about the shape first. Okay, so the distribution. And what are we looking at? The students in a public speaking class gave a presentation, the links of the presentation. So how long? The distribution of the links of the presentation in a public speaking class So instead of saying is roughly symmetrical, we have to say is skewed left, or positive, by the way. Okay, so there's the shape. And we now will talk about the center with a, instead of the mean, since it's skewed, we need to discuss the median with a median length of, so where do we get our median? We get that right here on second page, median length of 17 minutes. Okay, now we have to discuss the range. And so in that case, since this is considered skewed, we have to look at the quartiles 1 and 3. I'm sorry, yeah, 1 and 3, and then the min and max. So 100% of the data falls within the min and max. 50% of the data fall within the inner quartile. So that's how you will describe the range. So all the presentation links were between. So what were the min and max? Well, 7 and 23 minutes with, now we'll use the interquartile range with the middle 50%. That's what the IIQR is of the links will be between Q1 and Q3. Okay, so I have discussed the shape, skewed left. I have discussed the center, in this case, the median, because we have a skew. And I have discussed the range. And since it's skewed, we have to look at the min max. So we have all of the data between 7 and 23. So there's the min max. And we have 50% of the links are between Q1 and Q3. So we've used our 5-number summary to discuss this particular set of data. Okay. Okay. Last thing, when you do your homework, please follow this procedure and discuss the shape as we have done today, the center and the spread. Even if the solutions in the book are a little less descriptive, if you follow how we did it today, it'll help you not only on your tests, but as well in the future as you guys progress mathematically. We'll see you in the next video.